Very well. So we're going to talk about multivariable functions today. Multivariable functions. So let's go back to elementary calculus. Review a little bit. Recall that. Let's do a little bit of recall. Recall that in algebra, in calculus, we learned that y equals to f of x, which represents a function, all right? We say that, hey, x is a free variable. It means that you're allowed to use the numbers that are part of the domain for your x. After you plug those into the function, you get some output back. So here you have a free variable and y depends on x. Very good. One free variable and the function. Okay, for one variable function, you define the domain, all right? The domain of the function d of f is the collection of, is the set of all x values such that y or f of x is defined. So in the set theory language, we say that the domain is the set of all x values such that, with the condition that y or f of x is defined. Well, you have one variable, one free variable, and you have the output value. Now, what if we have two free variables? Definition of a multivariable function. A function with more than one free variable is called a multivariable function. In this case, a two-variable functions, three-variable function, and so on. Multivariable function. So suppose x and y are free variables. Your function has output value z equals to f of x and y. So it means that you can freely choose x and y. X is free, y is also free on that domain, and the z is the output, depends on x and y. Well, okay, how do I define the domain in this case? If I want to define the domain of this function, instead of having just one value, one x value, my z depends on two values. It means that my z depends on some points or their pairs. It's going to be the set of x, comma, y, x and y values such that z or f of x and y is defined. Okay, so what's the difference between these two? When you're talking about the domain of a function with one free variable, this domain is a subset of real life. Okay. If you have just x and y, then domain is part of your x-axis. For example, the domain of the function is just an example. This is the domain of function. For a one variable function, the domain is an interval, just an interval. However, when it comes to a function with two variables, the domain is the set of points. So if you want to visualize the domain of, for example, two variable function, it's not just one interval, it's going to be part of the plane. For example, here you have this rectangular shape as the domain. This is just a collection of points on the right. D of f, which is a collection of points. Your machine takes values from the domain and assign a z value, the output value as z. So you are taking x and y. This is just x comma y. And it makes some changes to this point, to this x and y. This is your function, this is your machine, and gives you some output value back. When you're talking about free variables, it means that you can freely choose that variable. For example, when it comes to an algebra function, like y equals to like x squared, I can freely choose any number that I like for x. X can be 1, x can be 2, x can be a half, x can be square root of 2, negative a third, and so on. I can freely choose x. And after doing the calculation, it gives me my y back. For a multivariable function, you can freely choose x and y. There is no restriction on x and y as long as they belong to the domain of the function. So in that case, for example, you have z equals to x plus y to the second power. This is a function with two free variables. I can freely choose x to be 1, y to be 2, x to be 0, y to be negative a half, and so on. I can freely choose these values for my x and y. After I plug those into the function, it gives me the output value back.